Chapter 13, Section 5 is on chain rules for functions of several variables. The objectives are to use the chain rules for functions of several variables and find partial derivatives implicitly. This theorem 13.6 is the chain rule where you have one independent variable. You have w, which is a function of x and y, and x is a function of t and y is a function of t. Then you can find the derivative of w with respect to t by finding the partial derivative of w with respect to x times the derivative of x with respect to t plus the partial derivative of w with respect to y times the derivative of y with respect to t. This diagram illustrates the relationship between the functions and the variables and those partial derivatives and straight derivatives. So what we have here is w is a function of x and y. So we have an equation w equals something with x's and y's. And then you have another equation where you have x equals something with a t in it and y is equal to something with a t in it. So you're really dealing with three equations here. You want to find the derivative of this top variable w with respect to that bottom variable t. You find that by going along the branches. Now, since w is a function of two variables, you must take partial derivatives. Partial derivative with respect to x and the partial derivative with respect to y. Since x is a function of a single variable, you take a straight derivative, the derivative of x with respect to t, and since y is a function of a single variable, you can take the derivative of y with respect to t. Now take a look at these branches here. If you multiply the branches starting from the top w to the bottom t, you multiply these branches together, and that's where you get this first part of the derivative equation. The partial of w with respect to x times the derivative of x with respect to t. And then follow along the branches on the right side. The partial derivative of w with respect to y times the derivative of y with respect to t. And you're going to add those two together. So you multiply going down from the top to the bottom, and then you add all of those branches together. That's how you can find the derivative for a function of several variables when you have a few equations and you're using partial derivatives. Here's an example where we have w equals x squared y minus y squared. So again, w is a function of two variables. And you have another equation, x equals sine t and y equals y equals e to the t. Find derivative of w with respect to t when t equals 0. And we're going to be using the chain rule with partial derivatives. So this is the formula that we're going to use. If we look at w, take the partial derivative of w with respect to x, you treat x as a variable and treat y as a constant, and that derivative here, the derivative of w with respect to x, is going to be 2xy. And then we're going to multiply by dx dt, which is the derivative of sine t is cosine t, plus the partial of w with respect to y. You're going to treat y as a variable here and x as a constant. So that derivative is x squared minus 2y. And the derivative of y with respect to t is e to the t. All right, so that is how we get this step here. Again, we're taking these partial derivatives of w times the straight derivatives here of x and y. Now notice this derivative of w with respect to t is an equation that has x's, y's, and t's for the variables. We're going to substitute what the value of x is and y so that we get this all in terms of a single variable t. So by making those substitutions and simplifying the results, we can find that when t equals 0, plug in 0 in for t into that result, we can find that the derivative of w with respect to t is negative 2. Okay, this chain rule in theorem 13.6 can be extended to any number of variables. For example, if each x of I is a differentiable function of a single variable t, Then for w, which is a function of x sub 1, x sub 2, all the way up to x sub n, the way you would find that derivative of w with respect to the variable t is to take all those partial derivatives and you're going to multiply by the straight derivatives. I always find it best to draw that picture so you can see all of the branches when you're working out these partial derivative problems. Okay, so here's an example where we're using the chain rule, but we have two independent variables. W is a function of x and y, and x is a function of two variables t and s. Y is a function of two variables t and s. So we can find the partial derivative of this top variable w with respect to the bottom variable t by going down the branches, multiplying down the branches and adding the results. So the partial of w with respect to s, start at w and end in s, and look at the branches going down. So the partial of w with respect to x times the partial of x with respect to s. That's our first part here. The partial of w with respect to y times the partial of y with respect to s. That's where we get this part here. And similarly, if we wanted to find the derivative of w, the partial derivative of w with respect to t, start at the top of w and follow the branches that end in t. You multiply going down and then add the results. So the partial derivative of w with respect to t is the partial derivative of w with respect to x times the partial derivative of x with respect to t. And plus the partial derivative of w with respect to y times the partial derivative of y with respect to t. In this example, we're going to use a chain rule to find the partial of w with respect to s and the partial of w with respect to t. If w is equal to 2xy and x equals s squared plus t squared and y equals s divided by t. To find the partial of w with respect to s, we're going to use this formula. The derivative of w with respect to x is 2y. The derivative of x with respect to s is 2s. The partial derivative of w with respect to y is 2x. And the partial derivative of y with respect to s is 1 over t. Now we're going to make the substitutions. We're going to replace the y with s over t and replace the x with the quantity s squared plus t squared, so that we get w, the partial derivative of w with respect to s, in terms of the variables s and t. Okay, so by making those substitutions and simplifying, we get this is our partial derivative of w with respect to s. Okay. Now if we want to find the partial derivative of w with respect to t, we are going to hold s constant and we get the partial derivative. These two are going to be the same, the 2y and the 2x. The parts here, this is going to be your partial derivative of x with respect to t and the partial derivative of y with respect to t. Again, by doing the substitutions, replace what x and y are equal to in terms of s and t, simplify the equation to get the result.